Hello, everyone. So this is the last talk of the day. I'm sure you're pretty excited to explore Bangkok, as I am. I just need 15 minutes of your time. I hope it'll be worth it. My name is Gaurav. I work at the product security team at Red Hat. This talk is around open source security. So anybody directly works on security is involved with any security related work? Okay, that's great. So this is a brief agenda. We'll be talking about what the challenges are with open source software today, what we can do about it, what's the status quo, and what are the possibilities. If we have some time, we'll have some questions. As I said, I work with product security, but product security is really broad. If you want to pin it down, I work with the resilient development team. What it means is I help secure some of the Red Hat offerings from ground up, mostly around RHEL and OpenShift. I have an interest in security, Linux, malware, some emerging technologies like eBPF and WebAssembly. When I get some time, I do write. These are the places where you can find my articles. So, anytime open source security issues come up, there is a hype cycle. We are all interested in it for 1 day, 2 day, maybe a week, and then we forget about it, right? But what happens about it later? What to do if you want to know the trends? There are different ways of finding out, what's happening, what happened, how did we react, did something improve? One of the things to do is just read these reports which come up regularly. So one of these is from Sona. Sonatype is a company. It gives you a lot of background about the issue that happened, what happened. There is a lot of research that goes into it. So I'll cover what are the my main findings. Here is another one from Black Duck. It's about supply chain security and how to deal with it, what are the issues. If you look at it broadly, what it says is open source software is everywhere. Most of the applications today are using open source software. The software or the OSS components that are being used are getting big and they're getting more complicated. What it also says is, in spite of all the security work that we are doing, critical or important security issues continue to be discovered. So that's not getting any lesser. If that wasn't enough, there is a huge uptick in malicious open source software projects, which is another thing that we need to worry about. And it's not just the projects, it's not a problem on the project side. It's also a problem with the consumption of open source software. For example, if a critical CVE comes in, even if a fix is released, many months after that, they have found that a huge chunk of the downloads were still continuing to use the vulnerable software in spite of the fix being available. So that is a problem. So these were the problems. How are we currently dealing with the security of open source software? I think a central place for all security related issues is PCERT. It's just an incident response team. It could be around products. It could be around the open source projects. For example, if you want to report a security issue, where do you go? You go to the incident response team. You want to request a CVE, where do you go? It's the incident response team. Who works with the developers to get a fix, publish it, release a security advisory? It's again an incident response team, right? So they do a bulk of work. The team is evolving. They are heavily involved in the tooling aspect of it. The gist of this is where I'm trying to get at is still reactive work. They start with something once it's reported to them or once it comes in, and then they kind of respond to it. Okay, how can we be more proactive, right? So I was part of an incident response team a few years back, and we wanted to do more proactive security work. So that's where security development comes into the picture. So instead of being one step behind, what do we need to do, to secure software from ground up? Well, software follows a development lifecycle. Why not have a parallel secure development cycle running alongside with it, right? So when you have the requirements ready, why not, have the security requirements ready as well? Once you have the design in place, why not do a threat model and see what all threats are applicable to your software project and other mitigations in place? Once you start writing code, why not run it through a SAS scanner to identify issues quicker? Once you build the software and you are testing it, why not have security test cases where it will test the APIs for any issues? Uh, why not do a malware scan before you're delivering things to a customer? Because a lot of code that is coming from upstream might be tampered with. Why not do a penetration test? This is great. We are moving towards a proactive approach, which is great. But what can we do more? Threat intelligence. So threat intelligence is comparatively new, even though, let's say, a 10-year period. Currently, it's only applicable to places where infrastructure security is concerned, like many of your InfoSec teams or SOC. So the idea is to study the attackers, what their motives are, who their targets are, and really check what their methods are and come up with indicators of compromise and things like that. What if we can apply threat intelligence to a secure development lifecycle? What the possibilities are. So the security activities or the secure development lifecycle that you saw earlier is pretty much static. We are trying to build on generally known principles, like for a design issue, principles of least privilege or defense in depth or these kind of things. But those requirements are static. We are not taking into account what is happening in the wild, how the attackers are evolving, what are the components that they're going after. There's a wealth of information which can be translated and put back to the development lifecycle at each stage. What it ends up doing is give us a few key benefits. It is more proactive. It will allow you to focus on the threats that are relevant to you, instead of just trying to fix everything. We have limited time and limited resources. It does help with the remediation time, and it does empower your development teams. So I'm calling it threat-informed secure development lifecycle. So there's a secure development lifecycle, but what will change if it's more threat-informed? So towards the right, there are the key applications. I think this code summarizes it well. What it's trying to do is helping bridging the gap between your security requirements and your product development teams by prioritizing mitigations of relevant threats. So let's take some example, right? Probably you have 10 issues to fix. Which is the one that you fix, right? Earlier, it would have been with some kind of scoring, which has the highest score. But when you add context to it about what is being exploited in the wild, what are the attackers going after? So that gives you a wealth of information about what to fix. Same goes with patches. Your software is released, it's with the customers, right? They have like 100 patches to install, right, without breaking things. Which are the relevant patches that they install? Currently, it goes with the CVSS scoring. So anything about 9 is considered bad. But again, the context is important, right? Is there exploit available in the wild? Are attackers actively targeting it? Are mitigations in place? How is the customer deploying the software? So these things come into matter. So threat intelligence can help bridge that gap and help you with prioritize the patching. Identify vulnerable components quicker. So supply chain security is a big issue. If you remember the XZ attack, we were lucky it was detected earlier. Someone found a performance issue and started digging. And that's how we got to know about the issue later. But from finding it to getting the patch ready to distributing it is a huge cycle. If we know about it quicker by utilizing the curated threat feeds, we will be in a better position to respond to these type of attacks. Again, threat model and security architecture review is something a product security team does on a regular basis. But what if we had the knowledge of the latest attacks that are happening and the tactics or the techniques that the attackers are using? What we will get is more real-time, more robust threat models and security architecture reviews, which are in line with the current attacks. One of the reports that I shared earlier had a CVE, and what they said is it was an input validation issue, which turned into a vulnerability and which was exploited by an attacker. What if we had relevant test cases in a DAST pipeline, which would take care of your input validation? This issue could have been caught much earlier. So it could, in turn, help you with your test cases. When it comes to developers, just want to get things working. They are not, directly concerned with security. They want something working and working something immediately. So they might end up downloading a lot of components, a lot of libraries, without getting to know the complete background, whether the library is maintained, are there any security issues, and those kind of things. But what if there could be curated thread feeds which are targeted towards the developers, which can help them make informed decisions? And again, training is a big aspect of product security, which helps them to stay abreast with what are the key skills needed to develop secure software. Currently, the trainings are lagging behind in terms of just the best practices, but threat intelligence and the threat feeds can help getting the relevant attacks and turn it into trainings which are relevant for the developers. So how does one get started with threat intelligence, right? As someone, if you're a developer, if you're a single person, I would say start with the threat feeds first. Keep it simple. Just subscribe to a threat feed that is relevant to your industry. Maybe your area, maybe if you're a web developer, maybe you are working on a storage stack, maybe you're working on a financial industry, just subscribe to a threat feed. See what it's trying to tell you. It will tell you about the attacker, what he's trying to attack, and so on. Get used to the threat feed. The next step could be learning about intelligence cycle a bit, how threat intelligence team kind of collect that data, analyze that data, and put it into something which is actionable. There are some well-known models for threat intelligence. The famous ones are Kill Chain, the Diamond model, but I would highly recommend the latest, which is the MITRE attack framework. Many of the security tools today do incorporate the MITRE attack framework. So you, in a pane, you are able to see the attack, the issue, and it's tied to the framework directly. If you are brave enough, you could try a threat intelligence platform. So what a threat intelligence platform is a piece of software which takes feeds from multiple areas and allows you to do customizations around it that best fits your need. So OpenCTI is one of those frameworks which you can try out. Again, the last one is more generic open source, an open book about intelligence analysis. I'm not sure. If the above bulleted points caught your attention, maybe you could spend some time. It speaks about biases and how we view things and what are the biases that we encounter when analyzing something. Here are some general reading material about secure development. If you want to know more about how to securely develop software, what are the security controls that come into picture, what more can we do? There are some links about threat modeling as well as incident response. So an entire end-to-end description about product security. Yeah, that was my short talk. I hope I have a few minutes for questions.
Absolutely. Thank you. Question? Oh, okay.
Thank you for the talk. I just one quick question. You said that which are the issues that attackers will be attacking the most in my software. So how do you suggest to identify that these are the issues that would be more prone to attack, or attackers would most likely to attack these particular things?
Good question. So the trends are changing. Earlier, the attackers used to go attack the popular software or the main software components. But we are seeing a trend where they are trying to attack the developer chain. For example, Log4j is a good example, which was a logging library, right? And it happened to be one of the dependencies. Same with the XZ vulnerability. People weren't looking at it, right? But it was somewhere in the dependency chain, and that's what they exploited. So how do you go about identifying it, right? So I would say start with what your industry is. What are the crown jewels, who might want to attack it, and what their motivations are. So some motivations could be just script kiddies looking to have fun. Some will have financial motivations, trying to exploit it from a money angle. And some might be nation-state attackers who are trying to gain some information for espionage. So it depends on industry to industry. I earlier said subscribe to a threat feed. So threat feeds are generic, but they're also very relevant. So I would say if you subscribe to threat feeds that are relevant to your industry, you will start seeing a trend about where the attacks are happening in the real world. What are the packages or the components that they are trying to apply. So one of the things in the report was most of the open source is consumed via the repositories like NPM or PyPy. So the attackers are trying to attack these repositories so that people download these malicious packages. So yeah, I don't have a direct answer, but it's varied. Start with relevant threat feeds to get an idea about what the attackers are after, and that will give you a better idea.
You brought a really good point there that most attackers are attacking the repositories. Do you think using artifact repository management tools would be a good option to mitigate those risks?
It's getting popular. I don't know if it solves all the problems, but I think it adds one more layer. So it adds a maintenance cost, but it does have some benefits. So maybe yes, in some cases. Thank you.
Hello. Yeah, so I joined the talk a bit late, like 5-10 minutes, so apologies if you have already covered this concept. So I was trying to relate your talk with the concept of chaos engineering and was trying to understand if that can be the answers to the questions that he asked.
Sorry, I missed the word.
Chaos engineering.
Chaos engineering. Okay, chaos engineering, okay, good analogy. Chaos engineering is about injecting faults and trying to see if the system breaks. Make it more resilient. I think I wouldn't be able to relate it directly. This is more about learning about the attackers rather than doing things randomly. So chaos engineering doesn't, it just says that something might go wrong. Database becomes unavailable or a network cable is pulled or something goes offline, right? But here it's more about identifying the attackers, what they are currently attacking. So it's more real time. It's not like just assume a random case, but it's more about, okay, developers are targeting PyPy repository, right? So what if a malicious repository is kind of uploaded and a developer ends up downloading that? What will happen that? So it's more real time as compared to chaos engineering.
So basically you're trying to put yourself into the attacker's shoes and from their perspective and then try to harden your application and infrastructure.
Yes, but based on data, based on real data, which the threat intelligence team provides, who are monitoring the attacks in real time, and they are able to give you the information in real time, rather than going through the whole cycle where you will come to know about it much later, and then you will act on it.
Okay, thank you.
You'd see those as complementary? That information about active behavior by threats and also just randomly stressing your software two complementary ways of improving your process?
Sure, but randomly checking for issues is more from a testing perspective. It's more about having the system being more resilient. Security is an aspect of being resilient, of course. So yeah, that's a plus.
Just getting away from it. It's not an either or one is better than the other. They're tackling two different problems.
Overall, it would help. It would really
fair
help.
enough. All right, we could probably do one more if there's anything else. We've covered the topic so completely, there's nothing left to ask. Going once, going twice. I think everyone wants to escape. Thank you very much.
Okay, thank you.